So let me quickly introduce myself first. My name is Ameya Kanitkar. I'm an engineering manager at LinkedIn out of our Silicon Valley office. It's really fun for me to be here at New York. I really love New York. Uh, and this talk is about primarily how do we build and scale a data infrastructure platform as a service. We have a fairly large data science team. We have lots of analytics teams and lots of engineering teams. We are roughly about, I don't know, maybe like about 4,000 engineers, maybe give and take few hundred. So our focus is really, okay, how do we go and make everyone productive, right? And this challenge is not necessarily happens at 4,000 engineer scale, but really starts happening at much smaller number actually. So that's primarily the talk is about. So here's a question for all of you. What's common amongst these LinkedIn products? And I'll go some of them. This is the jobs you might be interested in. So we show you some recommendations on which jobs you can apply to. This is our news feed. You see what's updates and things like that. This is people you may know as really a popular feature and was the real driving force behind LinkedIn's growth, where we recommend who you can connect to. These are some of our internal dashboards. And this is the last one, which is about Talent Insights, which is our product that allows governments and other companies to make more interesting decisions. Like, say, Amazon wants to start a new headquarter. Where should they go and start? Where are the people with the right skills they are looking for, and things like that. So what's common amongst all these products, besides they are all LinkedIn? Well, the real answer is that they're all powered by data. They all have data behind them. And I think at this point, LinkedIn is around 600 million members across the globe. And that's great, right? But the real challenge is if you have lots of data, the real value of data comes only when you are actually able to derive insights from it, right? So yes, LinkedIn has a data-driven culture. We measure and monitor everything. Every single action you take, you don't take, but to really generate the insights, it's really about metrics, right? Metrics are very core at LinkedIn. Everything is a metric. How many people visit our website, how many people clicked on it, all the A/B experimentation, A/B testing experimentation, everything is a metric, right? So metric is really the unit of insight. You can call it. So yes, we have lots of data, and we have lots of metrics, and that generates your insights. So this talk is about actually metrics, like how we compute them, how we serve them, and how it serves the heart of our data science platform. Once upon a time, which is not like a very long time ago, but maybe 3 or 4 years ago, we had many multiple metrics platforms. To give you an example, we had an A/B experimentation platform, which in itself is actually a talk-worthy topic because it's very interesting how you do it in a connected graph when half of your friends, half of your connections are shown one experience and the other half different, and how they won't leak into each other and things like that. So there are a lot of interesting things about it. We have an experimentation platform. We had marketing metrics like, how many emails we have sent, and how many people have clicked on it, and things like that. We had lots of product metrics. We still have it, but we had a separate platform for it. So how is this particular product working? How is the engagement? What's the revenue, and things like that. Of course, we had executive metrics. Our daily executive dashboards just give a health of the business and things like that. And this is not an exhaustive list, but we had tons of people who built little scripts maybe on their machine, on their desktop, and they were serving those metrics for people. And I'm being generous when I say we had these platforms. Many of these were like small applications. And so the metrics landscape was very diverse. Yes, people were able to generate insights from what they were looking for, but it was very diverse setup. And this is bad. Why is this bad? The gist of it is that all these metrics and insights are actually all coming from actually a finite set of initial data sets. So we have a bunch of tracking data sets that are generated from the logs. And then we have a whole bunch of databases and tables and things like that. But what happens is that people start building their own ETL pipelines, their own applications in its own ways. And you can see in this slide, they have their own logic and their own apps, which in itself is not a problem. But what it leads to is inconsistent data. I'll give you an example. One of our dashboard might say that we had 5 million page views yesterday. And the other might say 5.2 million. The problem is we don't know which one is correct. We know one of them is correct, but we don't know which one is correct. And like this 5 million and 5.2 million may not be a huge difference, but once you start really analyzing the data, it really hurts, especially when you're actually selling this data. Right? Like a lot of our enterprise products are actually user-ending products. And if we want our customers to trust our data, we really need that consistency. Right? So that's lack of trust is the second point. The last one is that these are all closed systems and all the knowledge is in their own silos. So one team might have built something, and the other team may have no idea about it. We don't know the logic. And there are good reasons for it, right? For example, we always take this example of page views. But page views has some business logic behind it. It might be, hey, we'll count page views only after 1 second of rendering the page, or maybe 3 seconds after rendering the page. And somebody might change it a little bit later on, and now your page views number would be like now not just off 1 or 2%, it might be off 30%, right? And so you cannot have a consistent data with setup like this. So the challenge with this is data consistency, and that's where we started. But what we realized is this is not the only problem. The second big problem is that engineering productivity and operations. I'll give you an example. How typically build metrics, right? So somebody decides, hey, these are the data sets from where we want to build metrics. And somebody comes along, maybe the same person, maybe a different person, goes and builds an ETL pipeline to generate this into another data set. From it, then it might go to some sort of a OLAP system. We have our own open source system called Pinot. And then somebody might build dashboards. And then somebody might need to decide, hey, who should get access to it, who shouldn't get access to it. I'm guessing probably all of you are on LinkedIn, so we have data about all of you. We want to make sure that I don't get access to your data, right? Nobody should get access to your data. We are very concerned about PII and stuff like that. So somebody should decide who should have access to it, who shouldn't have access to it. And you know what? If you have noticed, there are only 2 parts in that slide. Insights and analysis and identifying data sources are the only 2 parts which are core to the discipline of data science, right? Everything else you do is repeat work, right? Every team is doing it. So that's a problem, right? How companies typically solve this? There are generally one other few flavors of this example, right? So we have group of data scientists. We have infrastructure people who would build, Hadoop and Kafka, things like that. And then there are some teams who are like ETL teams or data engineering teams. And if you're a small company, it might be all one and the same. If you're a large company, you might have a lot of silos and you're doing it separately. You have some data, some overlap, right? But this is problem, right? The speed can slow down a lot, right? If you want to build insights, you're not able to quickly iterate through it. We follow OKR, objective and key results structures. We have this quarterly planning. I'm sure you must have heard something. You went to some team and said, hey, I want this. Like, oh, our quarter is full. They come back next quarter. I haven't talked to any team in LinkedIn who said they don't have work to do. So yes, I'll do it right away. But the point is that everybody's busy, right? If you have more teams, especially at our scale, 3,000, 4,000 engineers, everyone has their roadmap, and it becomes just so much harder to coordinate as your teams grow. What are the other challenges? The next one is that, hey, if you are maintaining just one data pipeline, that's okay. But when you are generating hundreds of these, thousands of these, it's a whole another set of problems. Building and maintaining these data pipelines are messy. Managing the metadata, lineage, data dependencies, SLA is very complex. One of the funniest stories I had heard, not in LinkedIn, in one of my previous jobs, is is that one day one of the dashboard didn't show the right data. We're like wondering what's wrong, and we're debugging, and we found out somewhere upstream we forgot to pay one of our vendors, so he cut off the access, so no more data. So the point I'm trying to say is that even if you find and identify the issue, debugging it, who is actually responsible for it, and how do we make sure that the right people are in charge of this, right? It gets very messy. Okay, so what's our solution for it? So our solution is we said, okay, let's put together some sort of our wish list and build it. So one idea we had was that, hey, let's build a trusted repository of metrics and build a self-service platform. What are our wish list on it? So we wanted a consistent metrics and insights for all data applications, metadata everywhere. We want to have a consistency in metadata, a common agreed upon set of dimensions, let's say a member dimension or a country dimension, no duplication of metrics, allow data scientists to focus on their core job of building insights and understanding and analyzing it, and not worry about the data management part of it. And then increasing the engineering productivity and simplify and optimize operations. All right. So we built what we internally call UMP, but it's really a metrics platform as a service. Let's see how that works. So in conceptuality, this is very simple. What we want to do is that we want data scientists to write a little bit of code plus a little bit of config into our central metrics platform. And metrics platform does the rest. And I'll explain into a little bit more, but this is an interesting abstraction concept to think about. I call this as a third generation of abstraction. So what I mean by that, the first generation of abstraction was maybe 10, 15 years ago when we just figured out, oh, we have lots of data, we don't know how to process it. And people build systems to process that. An example is Hadoop, an example is Kafka, right? You have lots of data, how to process it. Then people realize, hey, we have all this data now, but we have MapReduce and all these systems, but we want to automate things, we want to make it easy. So people started building tools. So one of my previous teams, we were building Azkaban, which was a workflow engine. There are many workflow engines. People have built many tools to make things easy, and people are still building that. But this is a third generation of abstraction example, where what we are doing is not solving problem for everybody, for every single domain, but we are saying, okay, let's take one niche and just find and try to solve that problem by platformizing it. And I'll give you an example now. So this is how it works. Let's say you want to build daily unique users, right? So data scientists will come and write a metric named daily unique. They will say which input data sets they want. They will talk about the frequency, whether they want to compute it daily, hourly, real time, things like that, which dimensions they will do. They will also write a little bit of a code to actually add actual business logic and put this into our metrics platform. And metrics platform auto-generates all the pipelines necessary for it, right? You just write this little config and write a little code, and the platform automatically generates necessary ETL. We'll go to the right data sources, we'll pull the data, we have all the schemas, and has all the aggregations, so it actually computes, builds, pushes to the right stores, things like that. And the output is back to dashboards where you can have your last mile transformations. That's it, right? That's really the gist of the metrics platform. Okay, so we have built this idea of this third generation of abstraction, but this was not easy, right? So what are some of the lessons we learned in building this? So when we started this 3-4 years ago, we probably had a handful of metrics on this platform. Today we have over 20,000 metrics on our metrics platform. Pretty much 90% of metrics that are computed in LinkedIn today are built on this platform, right? So what are the lessons in scaling them? We have over 1,000 engineers and analysts using this. What did we learn? So not surprisingly, one of the first lessons was, hey, scaling governance is not easy. Building technology might come easy for us, but scaling governance is actually very hard. And it's ironic because that was the problem we started out with. We said, hey, we don't want inconsistent data. And even after this platform, we realized that scaling governance itself is not easy. But we figured out how to solve that, right? Or at least to a great extent. So first we started with a single repository. Any metrics you have to check in your code. We don't want non-checked in code, right? You can decide your norm, how much you want to code review and things like that, but it needs to be checked in a central repo, so it's searchable. Second, that we built a system of a governance model by subject matter expertise. So you check in your code, your metrics may be related to, let's say, page views, right? So there might be a team, horizontal team that governs that particular domain area. So your checked in code automatically goes to those subject matter area experts. So they can tell you, hey, maybe you're duplicating this, or this might be wrong, or whatever have you. So we have all these subject matter areas, expertise areas, and once you check in the code, it automatically goes to the right people who can review your code. We also built a lot of tooling around it. So we now have a data lineage tool. You can go and browse how and where your data is, where it's coming from, things like that. We have also built a first-class search and discovery experience. So now you can go to a tool, type the metric name or a data set name, search for it, and you can go to a particular location and find out what the logic was and how it was built, who are the people responsible for it, things like that. Second, in order to really scale this, what you really want to do is that you want to make sure that implementing default use cases should be easy, and complex use cases should be possible. What I mean by that is that if you really want, if you're not able to build this platform and people are not going to use it, you're not really successful, because you cannot solve the inconsistency problem. But in order to people to use it, we really have to make sure that people come up with all sorts of difficult and very last mile use cases, and your platform may not be ready for it. So we had to ensure that we build a platform in a way that the most common use cases are easy to solve. But if you have a unique use case, you can still onboard it, and it's possible. It may not be easy necessarily, but it's possible. So what did we do for that? So we quickly increased our support to number of languages you can write your logic into. We initially started with Pig, which was a historical language. Most of the MapReduce code was written in LinkedIn. And we quickly increased it to Hive, Spark SQL, Presto, and things like that. So people can write in all sorts of different languages. Templatize common patterns as quickly as possible, right? So we started out with cubing and automatic union steps. But we also added support for multi-data center availability, which was a very common use case, backups, percentile support, things like that, right? So we identified lots of patterns and templatized them. We built lots of downstream integrations. So, okay, I want this data in this particular store, in this system, that system, things like that. And also explore a plugin architecture so your clients can write it for you, right? So instead of your platform team being sort of the bottleneck, your clients can write it for you so that it's easy. Leverage economies of scale of being the central platform. So one of the things we realize is that by being the central team and by so many people using it, we as a company were able to actually invest in things that you would not be otherwise able to invest if you had different apps, right? And this is really powerful. And we at LinkedIn, we are fully doubling down on this leverage and economies of scale. I'll give you examples. So now this platform also manages your compliance, right? We had GDPR last year. I briefly talked about PII data. It's very hard to go to individual separate apps and bring that compliance in. Now that we had a single system in centrally located system, we implemented our compliance and user management, data retention. Like GDPR has a rule the data must be deleted in 90 days or 30 days, whatever it is. Who is going to ensure that? Because we have a platform, we are able to do it centrally. And data quality checks, these are all the things of leverage. We also build lots of tooling that, as individual teams, you won't be able to build it. An example of that, we built a very powerful backfill tool. The data, no matter what you do, some days data will be wrong, right? And you need to backfill it. So we have a very simple, easy to self-serve tool that you can go and run your backfills. We have also spent a significant amount of memory efforts in building self-fill tooling. So a lot of times, things fail in your pipelines, and our systems automatically detect the failure and automatically recover from it as much as possible. Right? And this is all done in a central way, so thousands of pipelines benefit from it with our investment. Right? If you are just running 5 pipelines, it may not be worth it, but at this scale, it makes a lot more and more sense. The last one is that, because you also have this common system, you can also build innovations and invest in innovations, and you also have a very large impact with that innovations. So we started out this platform as a purely an offline platform. Right? You compute it daily, hourly, monthly, weekly, things like that. And a lot of people were asking us, hey, we also want to build this real time. We want to see how many people saw my post in real time. Can you help us? And so essentially, we had Hadoop offline metrics, and people were wanting to find out how to do the Kafka, Samza-based metrics. And we were able to invest in a technology that would automatically convert your MapReduce code, your Pig code, or your Spark code into a Samza job, a streaming job, essentially, automatically. No changes required. You just write your code once, and boom, you have now real-time metrics. Right? These are the innovations. There are 2 benefits of, again, the platform. One is that we are actually able to invest in building something like this. Second, now we have built it. The benefit is now open to 90% of LinkedIn. Right? So in summary, we started out with 3 things common. Like I talked about metrics platform. We also built a dimensions platform because we realized that dimensions are also very common. You can platformize them. So we built a UDP or a dimensions platform. We had an API. Started investing in scaling governance. That helped us got us metadata and governance part of it, of the ecosystem. Then we built for customizations, which got us all these things. These are examples of downstream apps like dashboarding, experimentation, AI platform, features platform for machine learning, a product, and also different compute engines, Hive, Pig, Spark, Presto, things like that. Then then the next one was leverage economies of scale, right? So we started building more tooling for it. We built a backfill system, a self-healing system, a compliance system, and then finally evolve and innovate, building real-time metrics. And so that's kind of our journey and our lessons along the way. Thank you very much. I believe we have a few minutes, so we can take some questions. Yes?
So do you build this in-house, or this is using the cloud computing?
Yeah, good question. So just to repeat the question, did we build this in-house or a cloud computing system? So this is in-house system, yes. So we didn't use any vendor to build it. But having said that, LinkedIn has traditionally been, sort of our own data center thing. So it was largely built on open source technologies. Many of them we have open sourced it already. So Pinot I mentioned is open source. Azkaban is open source. We have a large team Hadoop contributors. I think we have one of the largest Hadoop contributors. So it's all built on open source technologies. Yes.
Can you go into a bit more detail about how you avoid duplicating metrics and data pipelines?
If I understand your question right, you said how to avoid duplicating metrics? Yeah, that's a good question. And that's why I said, scaling governance is not easy, right? Because I have to admit, even despite all this, we still have some duplicates, right? But they're far fewer than what we started out with. I think the key to that is that your metadata is very important, right? And a lot of times people think metadata is an afterthought. But because of our platform, we were able to integrate this system with metadata. Now you have a central metadata system which has all the metadata in it, and you have all the search and discovery on it. So that's one, right? So at least you can hope that somebody searching for session count or something can go and search for it and see there are no duplicates. Second is because we have the governance system where generally in your area, if you're writing some metrics, let's say for your product, how many people clicked on it or something like that, it will come to, your check-in will go to the people who are expert in that area. So they can tell you, hey, you're building a duplicate metric or something like that. So with those two, we have avoided some amount of, we have solved like 6, 70, 80% of the problem. But remaining 20, 30% still yet to be solved. Yeah. Yes?
How big's the team you have working on this?
We have about 10 people.
10 software engineers?
10 software engineers, yes. And one other thing I didn't talk about a lot is that, remember in that pie chart I showed you, data scientists, infrastructure engineers, and data engineers. We have pretty much eliminated this data engineering part here because your platform automatically generates all the ETLs, manages them, operates them. We operate it centrally. So you check in into thing and we manage it for you. You don't have to worry about it.
There are a couple of both paid tools and open source tools like a DBT or a Matillion that kind of seem to do similar type of work, but I don't know how long your platform has been around. Where do you see some of what you're doing at LinkedIn as being more advanced than what's available in those open source tools, and where do you see interesting things in the open source tools that you might be wanting to include? Yeah,
that's a great question. I think one of the challenges with this third generation of abstractions, again, I'm talking about, is that it's kind of specific to your domain, in a sense that we thought about open sourcing what we call UMP internally, open sourcing UMP, because we have a very open source culture. And what we realize is that a lot of our stuff is very unique to LinkedIn. How we manage compliance, how we do check-ins, how we do these kinds of things, and all the integrations are also what we use, right? We don't have integrations, for example, into some open source system, right? Having said that, I think this is the idea, if you think about this, right? I think we are in very early days of this third generation of abstractions. But the idea here is that find your niche, right? In this case, it's metrics, right? One couple of other niches we are exploring is features, like for your machine learning platform. And find your niche and see if you can build a platform around it, right? I don't know about any open source tools, actually. If you know, let me know, actually. I'd be happy to try. Any more questions? Yes?
You have multiple issues under LinkedIn, like marketing. So you have marketing, you
Yes.
have some software product pushing metrics, and they each have probably different versions that they're publishing. And I'm assuming your consumers can be anyone.
Yes.
So how do you handle the different versioning, the evolution of versions of these multiple teams publishing data in terms of making that easier for the consumer to handle the unexpected cases? I'm not sure if I made that myself clear.
Yes, I'll try to answer it, because there is a lot of context here. So I think the part here is that, I think if we all agree that there should be only one consistent metric for one definition, and if company agrees on that, then it makes it a lot easier. Right? You might have a metric that is a variation of that, but that's fine. You can call it A-B versus A-B, right? So you can have different versions, but as long as you have bucketed it into your own subject matter area, right? We also have a concept called public-private datasets. So what I mean by that is that you can build a dataset that only your team uses, right? And what we call them private datasets, right? But if you believe that your dataset can be leveraged by other teams, then you have a higher bar. Then we call them public datasets, and then you need to meet a bunch of other criteria. Actually, a lot of our datasets are actually public datasets. Like majority of them are public datasets, because we find a lot of leverage in finding each other's dataset. But yes, there are a lot of last mile transformations which are unique to you, which are unique to your team, and we don't bother. Then you can do it on your own. But yes, our customers are across all the orgs in LinkedIn. Maybe one more final question. Yes.
So you showed that the code that you guys allow is in SQL. Have you had users wanting more complex kind of code, like Python code that don't want to execute?
Yeah, that's a good question. So just for the example, I showed you a SQL code, but we do support full Scala, and we support full Pig, which is essentially a procedural language. So yes, essentially the integration points are we expect you to output certain variables in certain format and things like that. But once you do that, you can write any code you want. All right, thank you very much.